synchronization problem, right? So before enter into the problem, we must know what is semaphore. Okay, semaphore is an integer variable which is used to coordinating the process synchronization. Okay, so process synchronization in the sense whenever we are executing more than one process on the system, that time we need process synchronization, otherwise data inconsistency or some collision will be occurred. Okay, so there are three classical synchronization problems. So today I am going to tell about the reader and the writer process. So this is the introduction. Only one file we are going to share among reader and writer process. A reader can read the file, writer can both read and write the file. So these are all the problems. So allow multiple readers to read the file simultaneously, that is read and read is possible because all those processes are trying to access the data, not trying to modify the data. Okay, they are going to access the data only. Updation and changes of the values will not be permitted. Okay, so second problem, when a reader process is accessing a file, then the writer process is not allowed to access a file. When one process reading the shared file, that time we won't allow any other writer file to write the content. If we allow, definitely data inconsistency will be occurred. So read and write is not possible. When a writer process accessing the file, then no other process is allowed to enter in the access the file. That is, the write and read is not possible, write and write also not possible. If we allow read and write, write and read, that time data inconsistency will be occurred. Okay, so this is the problem. Now we are giving solution for avoiding the data inconsistency. Okay, so these are all the shared variables, shared data while we need implementing the code. Okay, one shared file we need integer count, that is integer reader count, which is used to identify currently how many users are accessing our file. Two semaphore we need, one is mutex, another one is write. So mutex now it is responsible for reading operation, write it is responsible for writing operations. Only one problem that is most important, one reader process is accessing, that time we don't allow any other process for writer. Okay, so this is the structure of the writer process. So in the structure, while true, so while true in the sense as always the condition is true. Okay, suppose P1 want to perform write operations now, that time it has to invoke wait function. Wait function in the sense with the help of semaphore we can perform two operations, one is wait, another one is signal. So wait in the sense we are going to decrement the value of the semaphore, that is decrement. Signal in the sense we are going to increment the value. Okay, like a switch on or off. Okay, so while we talk about the writer process, we must know the entry section, critical section and exit section. Wait of write is an entry section, writing we can perform under the critical section. After writing is over, we should call the signal function for making this green signal to some other process. Okay, this is entry, critical and exit section. So the initial value of write is 1. Okay, so suppose P1 want to write some content, that time it has to invoke wait system call. After invoking wait function, the value of write semaphore will be 0, which means currently one process are executing under the critical sections, no other process are allowed to write or read the content. Okay, so in that way we are achieving WR and WW is not possible, that is write and read, write and write is not possible. So by implementing this code we can achieve write and read, write and write is not possible. Okay, so once the writing is over, the P1 has to invoke signal, which means after once the writing is over, the write value will be incremented to 1. Okay, so this is the writer process. Next we are going to discuss about the reader process. Okay, so with the help of reader process we must define the condition, which is read and read is possible and read and write is not possible. Okay, so read and read possible now, already we have discussed. So mutex is a semaphore which is used to responsible for reading operations now. So mutex, initially the mutex value will be 1. After, if the process, for example P1 and P2 want to read some content on the shared variable or shared data, which means P1 has to invoke the wait mutex. That times mutex value will be 0, because wait operation it is similar to decrement operations. Okay, 0. Then RC. So initially RC value will be 0 when when the OS accepting first process, that time RC value will be incremented to 1. Okay, if the reader count is equal to 1, then OS will invoke wait function, because in the second condition, okay, in the second condition, yes, when a reader process, okay, in the second condition already we saw, when a reader process accessing a particular file, then the writer process is not allowed to access the file, so that we are disabling, okay, we are disabling the write semaphore. Okay, so that we are invoking wait of write. So now the write semaphore value, initially it was 0, so now, sorry, initially 1, so now it will be 0. Okay, which indicates no writer process will be allowed. Okay, so no writer process will be allowed na, we can achieve the conditions like read and write is not possible. Very good. So next one, these are all the code under the critical section. So once all the process after invoking wait of write, then the process has to invoke signal of mutex, because we can allow more than one reader to read the file. So now the mutex value will be incremented to 1. Okay, so now, suppose P2 want to read the data or access the data na, that time it has to check the value of mutex. Mutex value is 1 na, we can allow. Mutex value is 0 na, we can't allow, the process has to wait. Okay, now the mutex value is 1, so now we can allow P2. Okay, so under the critical section we can perform the read operations. Okay, so once one process has been completed the reading operations now, that time it has to invoke wait of mutex. That time the mutex value will be 0. Okay, so then we should increment the decrement the read count. So currently there are two processes, one process has been completed now currently we are having only one process. Okay, if read count is equal to 0, then we can invoke the signal of write, which means we have to ensure no reader is accessing that file right now. So that here we are checking if read count is equal to 0. If the condition is true now, the control will call signal of write. So now the write value will be incremented to 1, which means now it is a green signal for the writer process. Okay, whatever the process want to execute write operations, now OS will allow the write operations to the process to perform the write operations. Okay, so now this is the code for reader and writer process. Here we have two challenges, that is, one is starvation, another one is data inconsistency. So starvation in the sense, whenever more number of reader process came now, that time we should allocate the reader process to the processor. Okay, reader process, once all the reader process has been completed, we can schedule for write operations. That time starvation will be occurred, because a waiter process has to wait till the completion of the reader process. Okay, so that time starvation will be occurred. Data inconsistency, if multiple readers or multiple writers are going to access the same data at the same time, that time data inconsistency will be occur, because one reader can get the 10 as a value, another writer, for example, after updating the value, another reader can get 20 as a value. Okay, this is the data inconsistency. So for avoiding data inconsistency, we can provide semaphore as a solution. Okay, so up to this reader and writer problem is over. Thank you for watching.